Hello everyone. In this video, I'm going to talk about the crane or log lifting, timber log lift or timber crane. So I have designed this crane here, and I thought maybe it is a good idea. We just design, we optimize the design, the thing that the crane that I already has been designed, but we can just optimize that or improve its functionality or efficiency. So you can see here I have designed a new gripper because in most of case I have seen that all of these cranes are equipped with the gripper with a gripper that has two couple of piston and cylinder. Let me show you here. So these are for example, these are the typical cranes. That one, for example, this one is mounted on a trailer. Okay, so however, this one here is mounted on a self-propelled uh, machine, a hydrostatic machine, self-propelled, yeah, hydrostatic machine here. So you can see here it is a very large crane, has a gripper. In so many cases, I've seen that they are using just two pistons and cylinders to make these to be opened, the jaws to be opened and closed. And so here you can see the schematic of this figure of this crane. This is the trailer, then the crane, piston and cylinder, and here is the telescopic piston and cylinder. So this is the gripper, and this system is used for making this gripper to be rotated around this axe. So I have designed this new one here, new gripper with two jaws, but one couple of piston and cylinders. So these are all of these components that already have drawn them. And finally, this is the universal joint here. Let me show the universal joint here. This is the universal joint, and this one is for what? For gripper. All of the components of the gripper. You can see here. But in this video, I'm not going to talk about each of these components or to draw them from the scratch, but I'm going to show you how I assemble these components together, because assembling all of these components that are moving, for example here and here, so here and here and even here, all of these jaws, and let me firstly make this one to come down. Okay, let me fix this one here, for example. Okay, you can see here the jaws is opening and closing. But the problem here in assembly is that these components are not so easy like that, because we have to do some prevention to make them to avoid overlapping. And I'm going to talk about this technique named angle and linear mate technique that I'm going to do that in order to avoid this overlapping. Let me show. I have done two linear or distance and angular limit here. You see, it's this. What is this distance? Distance means between the distance that piston goes inside the cylinder, and angular means that this angle, you see, the angle between this one and this one, the chassis and the jaw, the right jaw. So if I am going to suppress them, look at here what happens here. Okay, you see what happens here? They overlap each other. Okay. So in this video, I will talk about the mating technique and also assembly of the joint, universal joint, and finally the gripper itself. So let me bring a new one, and a new assembly here. So in this process, in this stage, I will have to bring all of these stuff together. Not all of them, but the base and the feather here. Where is the feather? This is the feather and the arm. I brought all of them one by one. Okay. Okay. Let me do this one first. Okay. Made this one with feather with the base, and here with here. Okay. And secondly, I have to take this one here with here, and let me do this. Okay. And here, making coincident. At the same time, making the cylinder and the piston concentric. Okay. So what is the next? The next one, making this one concentric with here, and that's it. So let me show what is going on in here. So you see it can, let me first fix this one. Okay, I fixed. Okay, you see, but there is a problem. The feather is rotating, the angular rotation of the feather is 360 degrees. We don't need that. We just need something like this between this degree and this degree, because you can see we have considered this space here. We don't want this piston to go out of the cylinder here. So you can for mating and for limiting the angular rotation, we have to use this technique of limiting. Okay, so it is very easy, or maybe you already know that, but I wanted to use that and show that how it works. This one, mating with here. Okay, so you see that let me okay, angular. Okay, flip, let me flip it. Okay, not flipping like this. Okay, if I'm going to make that, I have, okay, so I can say if the minimum is 175, the maximum is 175, what will be my minimum? Let's do that 60. 60 is a lot. So let's do that 120. Okay, even 120 is a lot, because we don't want to make this one just vertical. It is close to vertical. We can say that 100 is okay. 120, 140. Okay. Yes, the distance between 140 and 175 will be even this one. We can this one make 145. 135. Okay, 135 is minimum. So make the, well, I'm going to change standard to advanced. Minimum will be this one, and the maximum will be 175. Okay, minimum 135 and maximum 175. Okay, here. So you can see here exactly. Okay, it's working. Let's bring the next stuff here. The next component is the feather, the arm. How I'm going to do that? I'm going to do this one. I think it's not float. Yeah, it should be float right now. Okay, let me bring it here. Okay, okay, and okay, and this one okay, and this one should be coincident with the space. Okay, that's it. So let me bring the other components. Again, we are going to use the same piston and cylinder. Piston and cylinder here. Okay, okay. Okay. This piston should be concentric with this cylinder as well. Okay. So it should be the same time. It should be concentric with here. Okay. Not here. Oh, it's not correct. It should be. Let me delete that one. Yes. Sorry here. So I have to make coincident and concentric with this one. Okay. 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 That's it. Perfect. So let me show what is going on here. Okay. Let me bring the other side, a couple of piston and cylinder here. So again, here and here, you can see that I'm going to bring them inside the assembly section. Okay. Here, let me bring here and here. So here, I have to take this one made with the feather here. Okay. And here with here. Yes, I think it will work. Hopefully. Yes. Okay. Okay. The next one is to mating piston and cylinder. Okay. And mating what's going on here? Okay. Okay. Mating this piston and cylinder here. Okay, and okay. So again, you can see here that we have again overlapping between this component, the feather and the arm. So again, here we have to do the same mating process here. So sample, so whatever, doesn't matter, sample 1 or sample 2. Okay, the same process here. Let me find the component, not the front, not the right, the top plane, mating with here. Okay, so if it is 2 degrees, how I am going to increase? No, I have to increase that until for example 90. 90 is okay. Yes, I think 90 is okay. Even we can do that 95. Yes, 95. So you saw that 95 is the maximum and the minimum was 2 or 3 or 5. Let me make it or 3. Okay, 3. I changed the standard to advanced. Okay, so here, okay, so you can see here that it goes here and here. Even let me fix this one, okay, to show you that perfectly. Okay, that's it. Again, floating this one, and let me bring the next component here. The next component should be again the same piston and cylinder to connect to connect the arm to the joint, universal joint here. Where is the cylinder here? I didn't bring that here. Again here, cylinder. I'm going to bring this one as well, and the stabilizer, and this one. Okay, the tension board. Okay, and okay, okay, and okay. So and okay. So let's do this one. Okay. Okay. Let me bring it up here. Okay, this one, mating piston and cylinder again. Okay. Okay. And this one should go here. Mating again this section with the surface. Okay. Okay. And for now, okay. So here, let me do what? To fix this one firstly. Okay, already fixed that. Okay, and okay. So here, I have to bring this one here. Okay, so here should go, I think, if I'm not wrong, it should be, yes, because it's going to make that one to rotate. Yeah, it should be go here. Mating this one with this one and this one. And where is that? Yes, here, this one with here. Okay. and again this one here, and this one with coincident with here. Okay, and so let me bring this one as well. Here, what am I supposed to do? Yes, this one goes firstly here to here, and this face with this face, obviously. So the next process should be mating this one with here. Okay, so yes, that's it. So what is going on here? You can see again we have overlapping here. What am I supposed to do? I have to do again the same process of limiting the angular rotation here. So if I'm taking this one here, let me firstly show what is going on inside here. To make that one transparent, so the cylinder transparent, so you see how the piston moves inside that cylinder here. That's it. So if it goes, for example, 90 degrees here, 90 degrees between this one and this one, it is enough. We have, it's okay. And even if it comes back exactly close here, even a little down, even a little down, this will be okay. Because why it's okay? Because we still have space here inside the cylinder, the head of the piston and the end of the cylinder, the inside end of the cylinder. But let me do this like this. You see, it's not overlapping because there is a space here. No, it is obviously it is all overlapping, so I don't have to make this one here. I have to maximum to make here. So let me bring the other stuff as well. The left stabilizer. Wait, tension bar, not stabilizer. The tension bar here. Okay, we have to make this one to okay, and okay. Yes, I have to bring it until here and until here. Okay, this component here is okay. So this component, I have to bring this component here, not the right, not the left, not the front, the top, mating with this surface here. Okay, so here you can see the degree is 122. 123 will be a lot. 120 is okay. So 120, if it is 120 the maximum, what should be the minimum? I can go minimum. Okay, if this is 90, I can go to 1 degree there. Yes, you can see here 1 degree. Between, let me change standard to advanced, 1 degree to 120 2 is the maximum. Okay, that's it. Okay, and okay. So you can see here maximum, minimum, maximum and minimum rotation. I have limited angular rotation of this connector. So let me bring the universal joint component as well. So let me go inside this file, the yoke, the swivel, and joint, and pin, not joint, pin, 2 and 3 and 4. Let me bring the second yaw and the other, obviously the other rings as well. Where is the second yaw? The same yaw, the same jaw will be the second yaw, the second jaw. Here, and again the pin. Okay, all of them again, and again, 1 and 2 and 3. Okay, here. This one should be mated with here. Okay, let me bring this one. Okay, let me mate this one here. Okay, and make coincident with this surface. Okay, and this one coincident with this ring as well. So the next, again, the same ring. Where is the same ring? This ring with here. Okay, okay, and make coincident with this surface. Perfect. Okay, so you can see here it's working like this. Okay, let me bring this one with here and this surface with here, and let me bring this one here, and so make that coincident with the surface. Perfect. Okay, the next component, the next jaw should go the next jaw or yaw. Okay, so here this one should be concentric with here, and this surface coincident with this surface. Okay, so again let me bring this one here. Okay, and make coincident this surface. Perfect. Okay, so let me bring the other, the third and the fourth pin here. The third one should, and again I have to bring that for the second time. Okay, and okay. So here let me mate this one with here. Okay, and here, that's it. And where is the last one? Okay, here you can see here with here. Okay, okay, and okay, okay, and okay. Okay, let me show you how it works. Fix this one. You can see this one is working in this direction, and at the same time it can be rotated in this direction as well. You see? Because of that we say universal joint. So what is the next? The next is the component of the the gripper. The gripper. Let me bring firstly the chassis and this one, the connector 1 and 2. Okay, make mating here. Okay, and making coincident this face with this face. That's it. Okay, so making this one and this one here. So and what I have done here, it's not, and this one with this surface. Perfect. Okay, so you can see that it should be rotating around this section, because of course here we need another mechanism to make this one to be rotated around this one, but it will be it will take a lot of time, so I avoided that. Maybe in the next videos I will design a mechanism to make this one to be rotating around here. See, again I'm showing you how it rotates. For example, let me fix this one. You see, this one is rotating, the chassis is rotating. Okay, let's make the component float again. Okay, so fair enough. Let's go to the next components, right and left jaws, or yaw. So here, okay, this one should be, okay, which one? Okay, this one, yeah, this one should be here. We have to fix this one here. Okay, mating. Okay, here, and go. Okay, that's it. Okay, okay, and okay, perfect, and perfect. Okay, and okay. And here, with here, we have to make that one. Okay, let's do this one as well. Okay, that's it. I didn't make mate here. Okay, perfect. Here and this face. Okay, and okay. And so, okay. And let me bring the piston and cylinder here. Not here, here. Okay, where is the piston and cylinder? The piston and cylinder is inside the same folder, piston and cylinder. And let me bring the rod as well, these as well, the rings as well. 1, 2, 3, 4, and 5. Okay, and 6. Okay, the piston should go here. Okay, coincident with here. Okay, let me bring, where is that? Okay, I don't have to make coincident because I have to put this ring here. I think this one should go, no, not this one. Where is the second? This is the, yeah, this is the little one. I think it should be, the smaller one should be here, hopefully. Okay, okay, so let me, okay, yeah, I think I am right. And I have to make this one with here. Okay, and I have to make the cylinder with the same ring here. I have to bring the other ring. This one goes here, here. Okay, go, 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 go. Okay. Yeah, not this one, obviously. So I have to delete that one. Okay, it should go, not this one, the other one. Where is the other one? So I don't have the other one here. Let me bring that again. The second one, the ring connecting a cylinder to the chassis. Grappler, this one or this one. Grappler connecting rod. Yeah, this one. I need 4 rod. I need 4 of them. I have to bring it again. One. Okay. So here again, mate with this one here. Okay. Okay. And the surface with here. Okay. That's it. Yes. So the piston will not hopefully move around there. Okay. And so, okay, here do I need, let me, okay, fix it. Okay. I need to bring the piston here and mate piston with cylinder here. You see, the piston and cylinder are simple here. In reality, the piston and cylinder are much complicated than this one. Okay, let me bring this one with this one here. Okay. Okay, let me show what is going on here. How can I show that? I have to make transparent the, I have made transparent the wrong one. Okay, I have to make piston cylinder transparent. What is wrong here? Okay, let me, okay, where is that, reveal that? Okay, transparent. What is going on here? I don't understand. Grappler and cylinder should be transparent. Maybe there is problem with the, Okay. So what is problem here? Let me fix this one firstly. Fix, okay. Okay. And you see here, it's overlapping. The problem is that these components are overlapping, passing through each other. So we have to make the other the other mating process here. Okay, so I made that cylinder finally transparent here. So let me connect the rod as well. Firstly, I have to connect or make a mate between the rod and, well, obviously firstly I have to make these rings to be mated with here. Okay, so perfect. And so I'm going to make coincident that one that ring with this surface, and the next one here I have to make that concentric with here and coincident with here as well. Okay, and okay, so here with here. Okay, so this surface make coincident here. Okay, so I have to connect this one with one here. Yes. Okay, for here I have to do what? I have to bring the other. I don't have them here, so I have go back and retrieve, bring them here. Again, where is that grappler connecting rod? One and two. Okay, here with this surface, that's good. I didn't make coincident with here. Perfect. Okay, let me bring this one here. Okay, and this one, or maybe this one. I don't know, this one here. Firstly, here. And here. No, here. This surface made with this surface. Okay, and okay, perfect. So what is going on here? Let me show you what is going on here. So you can see again they are passing each other. which is abnormal. It's not normal. So what we are going to do right this time, I'm not going to make angular limit. This time I have to make a distance limit here. Distance limit, what is the distance? The distance between inside the cylinder. So the distance that this piston goes inside the cylinder. Okay, let me firstly make them touch each other. Okay, please touch each other. Okay, it's a little tricky here. Okay, and okay, and okay, that's good. Hopefully it's good. Let me see from the top if they are touching or not. Yeah, they are passing each other a little. Okay, a little again. Yeah, there is still space between them. That's okay. And so if, and let me make this one fixed. It's already fixed. So when they are touching each other, we have to do this one. So here the face, and I have to make the face of piston. For example, here, this edge. Okay, so what is the distance? The distance is 511 and point blah blah blah. So I am going to copy that. Copy. Okay, so I just copied that. What will be my, you can see here that, okay, what will be here? Okay, so here I'm going to make the same process here, made the same edge. Okay, okay, is that enough? Yeah, it's okay because they are opened very widely. So let's change standard to advanced. So if this is the minimum, it should be, I have to paste here the maximum. Okay, and okay, and okay, and okay. So you see here the maximum and minimum. Okay, so but what happened here? That we still have again another overlapping here. It's here and here. So to avoid that again, we have to do the next one here, the next mating here. This mating will be like as the previous ones, similar to them. I mean the angular one. So this component, where is this component? The component is here. So not front, not right, the top. Okay, mating that with here. Okay, let me do this firstly to bring them together. Okay. Okay, the same process. Okay, find this one, the top, mate with here with this face. Okay, the angular one. Okay, so let me copy this one. Copy. Okay. I am going to, okay, open that, open, go, open, 67, 70, 71, 2, 3, 4, 5, 6, 7, 8, 9, 80, 81, 82, 83, 84, 86, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. 100 should be enough. Same. 101 or 100. Yeah, it should be 101. Okay. So this is going to be the maximum, and I already have copied the minimum. I have to paste that minimum. Okay. So here. Okay. Okay. And okay. Yeah, you can see here it is working, and they are not, again, hopefully they are not going to pass each other. Okay, you see. So this time we have done that to make, yeah, yeah, this time they are not going to pass each other. Okay, again, you can see here. Let me save them as well. Okay. So here, let me float that one. I'm going to float that. It will be rotating all the sections. Okay, from the beginning, you can see here that all of these rotation here. So you already saw that all of these assembly section and assembly techniques that I use to avoid the overlapping float. Okay, yeah, here you see here, and is this one, yeah, it's already free, not fixed, floating, floating, floating. Okay, and here you see this one opening and closing. So, and even this one, you see universal jaw is working. Let me fix this one, for example. If I fix this one, you can see it's working here and working like as this in all direction. And fixing that, opening and closing same time. Okay, that's it. In the next video I will show you how to design this one, how to design the gripper, because the gripper is here, it is a little crucial. So because you see we firstly have to make them touch, and we have to make two types of limit here, distance and angle. At the same time, it is a little sophisticated because I have used just one piston and cylinder, couple of piston and cylinder and rod, and I will draw from the beginning. I mean, I will show you how I draw that, how I have drawn that from the scratch. Okay, and maybe I will show you how I have drawn this mechanism, this universal joint as well. Okay, the rest of them are very simple. You see, for example, here, this one, I can show that the scratch here. This is the scratch, and I have done what? I have done the main scratch. What I have done? Okay, what I have done is that I have made boss extrude here. This one. That's it. Okay, see you in the next video. Thank you so much for watching. And if you like it, just like it and subscribe the channel because I will upload extra videos in the future as well. Thank you so much.